Hello everyone, here we will discuss about the collections framework in Java. The collection represents a single unit of objects. That means group of objects will be represented as a single unit in Java programming. The collection is a framework which is providing to the user an architecture or template to store the data and manipulate the data by using group of objects. Java collections can achieve all the operations performing over the data, such as searching the data from the collection, sorting the data in collection, inserting the data into collection, some manipulation, and deleting the data from the collection. There is two interfaces available in Java collection framework. One is collection interface. We can import that using the java.util.collection statement, and another interface is map interface, which we can import that by using java.util.map statement. The Java framework is having a set of classes. That means Java collection framework is having set of classes and interfaces which is providing to the user with ready-made architecture or ready-made template to perform the Java collections operations, which is used to implement a new feature or a class. So there is no need to define a new framework instead of Java collection framework. So Java collection framework is sufficient to perform the operations by creating or implementing the new features by using the collection interfaces. Java collection framework represents many interfaces like set interface, list interface, queue interface, double-ended queue interface, and these interfaces can be implemented by using some number of classes with ArrayList class, vector class, linked list class, priority queue class, hash set class, linked hash set class, and tree set class. Here the hierarchy of Java collections is given here. Java collection is having set of interfaces. So first interface is list interface, then set interface, queue interface, and the double-ended queue is the sub interface or child interface to the queue. Like that, shorted set interface is the child to the set interface. Likewise, here we are having another interface, map interface, that is second interface in the Java collections. And here the map interface is having child interface, sorted map interface, and which is having navigable map interface. And here which is having the classes to implement those set interface, list interface, and queue interface, and deck interface, etc. So those classes are given here. The list interface can be implemented by using linked list interface or stack interface or the linked list class, stack class, vector class, array list class. So these are classes to implement the list interface. Likewise, here we are having linked hash set class to implement the set interface. Likewise, the sub interface of the set interface, shorted set interface, can be implemented by using tree set class. Likewise, here queue interface can be implemented by priority queue class, and deck interface can be implemented by using array deck class. Likewise, here the map interface can be implemented by using abstract map class, which is having again child classes, enumerate map class, and hash map class. Like that, here navigable map interface can be implemented by using tree map class. Okay, so here this dotted lines are indicating the implementation of the interface by using these classes. This arrow is indicating the extension of the interface. So here you see we are having the interface queue, which is extension of the class. Like that, deck interface, which is the extension of the queue interface, right? So here we have seen the hierarchy of the Java collection framework, and as per that procedure, we know interface will have set of methods and variables, but the methods will not have the body of the statement. That means when you are defining the method, for example void add inside the interface, we will have the method ending with semicolon. It will not have the body of the statement. So this body of the statement for this method will implement by the classes in Java collections framework. So here the interface can extend iterable interface, and which is implemented by all the classes in Java collection framework. This interface contains all the basic methods such as adding the data into collection and removing the data or deleting the data from the collection, clearing the data from the collection, searching the data from the collections. So those are all some basic methods in the Java collection framework. For example, to add the object, here we are using the method add. This is default method we are using. This method can be used to add an object into the collection. Add all, here this is adding all the elements in the given collection to another collection. Clear, just which is removing all the elements from the collection and removing the object, single object in from the collection. If there is duplicate values exist, then it will remove the first occurrence of that particular object. Okay, all these methods are implemented by all the classes in the Java collection framework. We have seen the classes in the previous slide. Existence of these methods in the interface are ensuring the methods are universal for all the collections. That means removing method, clearing method, adding all the objects, add single objects. So those methods are universal to all the collections. That is, collection interface is building a foundation on which the collection classes are implementing that collection interface. Here we are having the first interface, that is called list interface, which is the extension of the collection interface. Okay, so now we are going to implement the collection interface by using the classes which are given to this list interface. So when you are implementing the list interface, automatically you can implement the collections interface. So here the list interface is child interface to the collection interface I have given here, and it is dedicated to the data of list type, in which user can store all the ordered collection of the object. Here this is allowing the duplicate data in the Java collections. The classes are implementing the list interface are such as here ArrayList class, then vector class and stack class and linked list class, etc. Here all the subclasses can implement the list, so user can instantiate the object for given list with any one of these classes. So here I am giving the syntax to create the object x with ArrayList class. Right here we have to mention the data type. So this data type is wrapper class data type, not primitive data type. Okay, so here I am creating the object variable using the array list, which is implementing the interface list with some wrapper class data type. And next one is, here I am creating the reference variable y by using the class linked list with some data type, which is implementing the interface list. Likewise, third one is, here the vector class is creating the reference variable jet by using some data type, and which is implementing the interface list. And here the next one is, the reference variable jet is created by using the class stack with some data type, so which is implementing here the list interface. So here you see we are using any one of this class to instantiate the object or reference variable for the given list implementation. So here I am creating the array list variable So here this is the object variable or reference variable created by using the class ArrayList here to implement the list interface. So here this array variable object is here the string data type. Now we will see the definition for ArrayList class here. The ArrayList is one of the class in Java collections which is providing with dynamic arrays. That means the size of the array. Okay, suppose if you have the object X which is created by using the ArrayList, then which is implementing the some interface, right? That interface is here list interface, some data type. So here you are created the reference variable. So for this reference variable you can add any number of data. Okay, any number of data you can add, right, without mentioning the size of the array. So here we are not mentioning the size of the array, there is no fixed size. Okay, that's what we are saying, the size of the array is dynamic. So we can add the array by increasing the list, and also when you are removing the data from the array list, automatically then the size of the array will shrink or reduce. So the this can be done by automatically with the concept of dynamic array structure. Array list is not synchronized by default. What is the meaning of synchronization? Suppose if you have the object here like this, there is the thread concept. Thread 1 may access this object variable, at the same time thread 2 also may be accessing that same object variable. So we cannot modify the structure of this object, okay, by adding the element or deleting the element. You cannot access the, I mean, you cannot modify this structure of this array variable X. So in this concept we need the synchronization, right? We need the mutual synchronization here. So that should be performed externally. Internally there is no synchronization in the ArrayList class. So we have to apply external synchronization by user defined synchronized method. Here changing the value of an existing element is not an structural modification. Structural modification in the sense, as I told you, adding the element into object or deleting the element from the array list object. So here suppose X is having the value 10, 10 is modifying as a 12. This is not the I mean structural modification. Structural modification means we are going to add new element or deleting the existing element. So the number of elements in the array is modifying, that is called structural modification. Here the array list is allowing the user to access the list randomly, and array list cannot be used the primitive data types. That means, as I told you, when you are defining the data type for the array list, when you are creating the object variable or reference variable, here you should use wrapper class data type. Okay, we cannot use primitive data types like small int integer and character. So these are all cannot be used in the array list class. So we have to use here to define the data type wrapper classes, right? So that's what given in this statement. Here I am giving a single example. Here we are importing IO package and utility package. The class name is ArrayList EX. Then main method is given by receiving some command line arguments. Now I am creating the reference variable AL, which is representing the array list. So here I am creating this reference variable by using ArrayList class with data type wrapper class integer data type. Okay, this is wrapper class, and which is implementing the list interface with data type integer. Here I am going to add the elements into this array list variable. So here I am using the for loop, then my length of this array is here I have fixed as 105. That means 6 elements, 100 to 105. So the initial element starting with 100, then I am adding one by one. Initially I am adding here 100, then incrementing by 1, again going back, so checking. Now 101 less than or equal to 105, which is true, right? 101 less than or equal to 105, true. Then which is adding 101. Now again incrementing 102, which is less than or equal to 105, it is true. Then which is adding 102, again going back, incrementing the array value. So like that until 105 it will check. So 105 less than or equal to 105, then 105 also will be added, then incremented by 1. 106 less than or equal to 105 is false, then it will exit from this for loop. Now I am printing the values which are available in the AL. So it will list out all the values from the 100 to 105. So you see this is the array list symbol, square bracket, right? Then based upon that here we have added 100 to 105, 6 elements, as we have seen in this statement. Then I want to delete the element from the array list reference variable. I am removing the value which is available at the index number 3. So here index is represented 0, 1, 2, 3, 4, 5. Okay, 6 values, the range of the index from 0 to 5. Now this is the index number 3, so we are going to remove this. So after removing this I am printing the value of the values available in the object AL. So I am printing here, you see 100, 101, 103. 103 is removed from the AL, then remaining values are 104 and 105. Then here after that I am printing the values by using get method, okay, one by one, which is not using the array list. You see here I am not using the array list, right? Just I am using the reference variable to get the element one by one, right? So I equal to 0, so 0th index. So now as of now 0th index, first index, okay, second index, third index, fourth index. Okay, so I'm getting that size of the array is here as a 5. Okay, so now I equal to 0, 0 less than 5. Okay, 0 less than 5, then which is true, a of get of 0, 0th index value, this 100 is printed here. Then incrementing by 1, so 1 is now less than 5, okay, which is true. Then the first index value is printed here, that is 101. Then again incrementing, so here 2 less than 5, which is printing the second index value, that is 102. Then third index value, fourth index value. When it becomes 5 less than 5, it is false, so it will come out of the for loop. There is no other statements, then program is closed here. Okay, so based upon that, you are observing here we are using the array list class to implement the list interface. Here you see we are adding the elements without representing the size of the array. There is actually in primitive data types, in array we will represent the size of the array, right? So here we are not representing the size of the array. That means dynamically we can add the elements and remove the elements. So here the add is the method to add the elements, remove is to delete the element from the array, and here get is to access the element from the array list. Thanks for watching.